Azeem Ahmed, Director of Engineering and Data Platform at Shopify. Welcome to the Data Exchange Podcast.
Thank you, Ben. Thank you for having me.
All right.
Excited to be here.
All right. So Director of Engineering and Data Platform. So briefly describe what that means in the context of Shopify.
Sure. So Data Platform of Shopify is our central team to aggregate data across all of Shopify and provide the primitives and the APIs to all data scientists, machine learning engineers, and the rest of the Shopify engineering community to use the data, transform it, gather insights from it. So we're an engineering team that focuses on leveraging the infrastructure, building the infrastructure necessary to deliver on that, building products necessary to deliver a smooth paved path for transformation, creating the right experiences for our users, whether it's how they find the data or how they experiment using the data that we have. And of course, part of our teams are responsible for reliably running the infrastructure and making sure that we're always up and running. So that's what we do with the data platform. And just a bit more context, data platform of Shopify is within the Commerce Intelligence Organization. Commerce Intelligence Organization as a whole is focused on making sure that we can leverage our data and enable the rest of Shopify to create unfair advantage for our merchants.
So data platform usually means a bunch of things. So there's the BI, reports, dashboards, analytics, which means people running ad hoc queries, and then all the way to ML and AI, and then actual data applications. So so this is what we're talking about.
This is exactly what we're talking about. We're talking about the breadth of all of these things. So let me take a step back and actually maybe talk about how I think about the data platform at Shopify in particular, right? In particular, we think about three large primitives: the ingest primitive, the ingest interface, the transform interface, and the publish interface. And all of these are working on, I would say, a data set as is our resource, right? And they could be tables, they could be models, they could be reports, dashboards, and all the other things that you mentioned. And when you think of ingest, transform, publish, these are all operating on a set of storage. In this case, we're building the Lakehouse architecture. Our storage is GCS, Iceberg table format plus Parquet. We use streaming ingest using Kafka Connect, and we grab all the immutable events as our Kafka tracking events, materialize them as Iceberg tables. We get all the change data records from our MySQL tables and whatnot, materialize them as Iceberg tables. I should actually correct myself there. We are in the process of materializing them as Iceberg tables. Historically, we have just used Parquet or JSON. We're converting everything to Iceberg now. Trino is our query engine. So that supports all of your ad hoc queries that users want to come and run. And then the transform primitives, once we have all this data collected and available, we think about transform in three modalities. You either have like full data set transforms, you take the entire thing and you want to transform it. You might have incremental data transforms, but at some frequency where you're taking all the new data that has come since the last time you transformed and transforming it again.
So and then you have transform in Spark.
Correct. So I'll go over the specific engines we use because we have.
By the way, Azeem, I'm happy to hear you guys are using the Lakehouse, right? So
Lakehouse architecture, yeah.
Because I actually was part of the team at Databricks. We wrote that post. What is a Lakehouse?
Yeah. I was actually it was pretty neat. I mean, we definitely were inspired by that concept of Lakehouse from Databricks, right?
I think actually, what do you think? I think actually it's the way to move forward for companies because especially recently, I don't know if you saw, Databricks just proved that you can beat a classic data warehouse even on SQL workloads with a Lakehouse.
I saw the post. I saw the back and forth that's going on between Databricks and Snowflake.
Yeah.
Well.
But then that shows
I saw that post. Yeah,
you can have your classic warehouse, but then now you have the future. You're future proof, right? So you can do ML, and all these other things with an open, and they have
with an open ecosystem. Right, exactly. Yeah. No, I'm certainly. I think it's definitely the way forward, right? I think having Historically, we have had Redshift. We still have BigQuery. And the amount of time that's spent in transferring data back and forth to leverage them in these systems is actually not just costly from the perspective of just money, but also costly in terms of time, right? So I think Lakehouse has a huge potential there. So the way we think about it is, hey, let's, we have a query engine, Trino, and we've got our data sets, and we should be able to optimize those data sets and optimize the query engine so we can get the same value. In fact, like one of our biggest goals that we've pursued this year, I don't know if you've seen some of the Shopify engineering blogs, is that our Trino latencies for P95 queries should be less than 5 seconds. And the reason we wanted to get there is because in some cases the data is not optimized, some cases the data is not in the right format. So if we can change all of that and actually get to a point where all of our ad hoc queries can run, not all, P95 ad hoc queries can run less than 5 seconds, it will be a huge boost for productivity for our data scientists, for anybody else who wants to query.
So what's your platform? So you guys are not on S3, I assume, because you're Shopify.
Yeah, we're on GCS. GCS. Right. So I mean,
so object store, right? At the end of the storage is an object store.
Correct. Yes. Yeah. So we're in GCS, and Iceberg is particularly useful from that perspective for us.
And that's another great thing about the Lakehouse, the separation of storage and compute, right?
Absolutely, right. So now I always I think I use the term it's a deconstructed or disaggregated database of some sort, right? So your compute and query, like if you think about a database engine, right? Ultimately, you have storage, you have the engine, and you have a specific SQL language that you can use to query. And if you look at a data platform in general, ultimately that's what we're trying to provide, right? But it's just disaggregated. It's deconstructed, and you have different parts just because of the volume of the data we're dealing with, right? So your query is a separate engine, your and separate set of workers and the compute engine, distributed compute that runs there. Your storage is in GCS, optimized for a specific type of query engine, and your transformations, which I guess could be compared to your stored procedures in databases if you wanted to think about that, right? Are built on these huge compute engines like Spark and Flink that we use.
Yeah. So here's another, for our listeners, here's another advantage of the Lakehouse. You can use whatever you want, Python, Scala. You're not limited to SQL. So of course, if you want to use SQL, you can use it. But if you want to use a programming language, then suddenly you have access to whatever objects, classes, functions. You can write code that you can actually maintain and read later, right? So.
Yeah, absolutely. In fact, I think that ties very well into our transform primitive. The way we think about our transform primitive, we think about 3 modalities for transformations and using 3 different languages, right? So we think about your full data set transforms, your incremental transforms, and your continuous or streaming transformations. And then each one of those, ideally, we don't support it today, but ideally we want to be able to support them in SQL, Python, and JVM-based languages for a user. So some users can use SQL. A lot of our SQL use cases today are full data set transforms. We recently introduced incremental transforms. A lot of our Python use cases are full data set transforms. Some are incremental. And most of our JVM-based use cases are actually streaming transformations today on Flink, right? But there is a demand for the streaming transformations to be available in Python because most of our data scientists are most familiar with Python, right? So Lakehouse architecture certainly gives us that flexibility that we can actually deploy all these 3 languages to do the 3 types of transforms that we want to be able to do and publish the data sets that need to be published.
So Azeem, what's in your particular Lakehouse at this point? So what's the breakdown between structured and unstructured data?
It's a very good question. I actually think we are behind on unstructured data, right? I think majority of our data, I shouldn't say majority of our data, I think majority of our usage is around structured data, right? We have unstructured data, but we don't yet have a clear pattern.
E-commerce is all about all the little thumbnails, right?
Yeah, there is a lot of structured data to actually leverage from. I think the unstructured data like images and whatnot, we have some really we have done a lot of work to
and text, right?
And text, absolutely, images and text.
Yeah.
And there is some good work that we have done last year to actually leverage that. But when I think about just the data platform itself, right? And I think about is there a paved path for somebody to come in and use unstructured data in our data platform today? I feel like we have a lot of improvements to make there. But having said that, last year, it's available on our engineering blog. We built entire product classification pipeline actually on Ray. It was originally built using Spark Streaming and Google Cloud AI. Now it's being deployed on Ray. But that product classification pipeline is a deep learning pipeline, uses images, text, and does some interesting things with it for product classification.
But in your mind, the Lakehouse architecture positions you well for unstructured data too, right?
It absolutely does. Yes, it absolutely does. I think we haven't paved that path yet, but it is certainly one of my concerns moving on to the next year, because I think we will do a lot more of these type of work that we did last year, like the work that we did for product classification. Not we, but the machine learning teams that did. We have to enable those teams. So I feel like it's something that we need to actually define how we're going to do it and what are the patterns that people can use. We haven't done a good job at it yet. But absolutely, I think having the Lakehouse, pursuing the Lakehouse architecture allows us to enable that for everybody at Shopify.
So before we go into Shopify use cases, I want to ask you kind of put you on the spot here, since you've been in a bunch of places, built a bunch of data platforms with many different teams, because I've been thinking about this recently, right? This notion of the modern data platform, I've been talking to a lot of these data engineering startups, and they started using this phrase, modern data stack. But actually, in my mind, the right term probably is modern data platform, because what they mean are these cloud warehouses and lakehouses, so Databricks, Snowflake, Redshift, BigQuery, Synapse. But when I say they're talking about it, they assume that users are already on one of these, and then they build whatever whatever it is they're building, ELT or data quality or data catalog and discovery. And then I started thinking, when you and I probably started even like 5-6 years ago to build one of these data platforms, you would have to cobble together Hadoop, Hive, Spark, right? So but now I think, honestly, many teams can just go Databricks or BigQuery or Synapse, right? And they get started right away. And by the way, I've actually even encountered people building applications with the assumption that people are already on one of these modern data platforms. So with that said, if you were to start a team right now, set aside Shopify, it makes sense to go to one of these modern data platforms, right?
I think number one, yes, it does. And I'll tell you why it does. Because I think a lot of times when you're starting, I learned this phrase from one of the folks I worked with at LinkedIn, Eric Balderschwader. So he talks about assemblers versus builders, right? So I think when you're starting and you're early stage, it's actually the right thing to do to assemble your data platform, right? And in the past, the assembly meant what you described, Hadoop, Hive, and pulling all of that together. And now you have a pre-assembled deck, right, that you can pick from, right? Whether it's Snowflake or Databricks or Redshift or Synapse, right? And absolutely, when you're starting, it doesn't make sense unless you are actually building a data platform. But it doesn't make sense.
You might be a very small team at that point, right?
Yeah, exactly. So you're a small team and you have a business problem to solve. That's not the core of what you're building, right? If you're a Firebolt, you're not going to go grab Synapse as your thing, right? But if you're solving any other problem and you have needs around data, it makes a lot of sense to pick something that's out there and just work with it. I think at some stage, as the companies grow, right, and you go from the starting stage to scaling stage, you have to, there are a lot of factors to consider,
Right.
cost factors, integration factors, and all these other things, including scaling.
Compliance.
Compliance, exactly, yeah. So all of those things in consideration, you kind of, some companies shift into builder mode, where they start building either parts or all of the data platform, right? So I quite like the way Eric put it, assemblers versus builders. So I do think like when you're starting, there is actually the modern data stack or data platforms have actually matured quite a bit, and there are some really good options.
They have an ecosystem now.
Yes, they absolutely have an ecosystem, and like DBT and all these other folks who are building Fivetran, all the folks who are building around, they're building around this ecosystem. So like, they're building for Databricks, they're also building for Snowflake, right? So you go somewhere, you can pick from them, and you can actually accelerate your journey quite a bit.
By the way, I started thinking about this, this notion of the AI flywheel, right? So you have a model, you get users, it gets better, and then, So I think there's some kind of virtuous cycle with this modern data platforms too, because now they have enough users, so then the tool builders are building around them. They get better, they get more users, more tools.
Yep. Absolutely. Absolutely. I mean, this is true, right? Anytime you build a platform that's actually a good platform, right, and then you enable development communities around you, it becomes a sticky. I mean, so I think we haven't found an AWS for data platforms yet, right, or a GCP for data platforms yet. So there are no like GCP, AWS, Azure, maybe. Like there are like some clear winners, right, in the cloud space. We haven't found one of those yet, but I think some are emerging, right, and it's very likely that when that happens, it'll be a simpler decision to just say, hey, let's do this.
So talk to me about Ray. And by the way, to our listeners, full disclosure, I'm an advisor to both Databricks and Anyscale. But as many of you know, I'm a neutral arbiter in some ways. I give you good information. So anyway, talk to me about Ray and Shopify's journey in Ray.
So I think let's go back to the transform primitive. Like I was talking about the primitives, right? So you've got transform primitives for data, large amounts of data. You're taking data and you're transforming them. But there is another kind of transformation that requires heavy compute. And like Spark, Flink, and these systems are built around the idea of a unit of data that you're processing, right? And where I think Ray is different and excels at is built around the idea of a unit of compute that you need to scale, right? Not just taking a piece of data and then you just need to distribute it everywhere and process it, as opposed to a unit of compute that you might have 5 of those, and then you need to distribute them and parallelize them. And that's really useful in the ML training, reinforcement learning, deep learning, all you can imagine, right? We're CPU heavy and GPU heavy. So our journey here, we started off, I think it's probably true for a lot of different companies. ML platforms are hard to build, and they're not just hard to build. The ecosystem is evolving so fast.
Before you go any further, once again, so is there an ML platform I can just take off the shelf?
No, I haven't found one yet. So if you know one, then tell me.
That's exactly how I feel too. But were your guys' journey kind of gradual?
It absolutely was. Yeah. So this is the third iteration of what we have now as an ML platform. The first one was we just used Spark was our workhorse. We used Spark, right, for some of the ML workflows. And it worked for the time being when we were using it. Then we moved on to Google Cloud AI. We tried that for a while. We ran into things like the type of the different libraries that we wanted or the version we wanted not being available and that type of thing.
Yeah,
it was inhibiting.
When we do surveys about NLP and the cloud comes up, people bring up the two challenges: tuning, I guess the tuning, customizing, right? Because who knows if the model will work off the shelf for your specific domain, right?
Exactly.
And then third, cost.
Yeah, Absolutely. Cost was not as big of a concern for us, but definitely tuning and customizing was a big concern for us. Cost was perhaps not a big concern because we were not heavy users yet, right? And then going forward, data and ML is going to be it's going to play a significant role at Shopify, right? In general, as you can imagine, we're focused on creating the right outcomes for our merchants, and we're a bit unique in one perspective, which is the merchant.
What's the vision around ML? By vision, I mean, is your goal to have a bunch of data scientists building ML models, or is it going to be an ML in Shopify will be kind of low code, no code, or somewhat autonomous? So what's the vision around the ML platform? So what's the usage?
We're not a low code, no code yet. Yeah. Right? We haven't talked about that, or we haven't pushed on that, because the way we build products, right, is we don't want to focus on ML for the sake of ML. Yeah. We usually think about, hey, this is the product. This is specifically the thing we need to help our merchants with. This is the data that we can use to help our merchants with, because we are a bit unique, because we are, the data belongs to our merchants that we have, right? So merchant data belongs to our merchants. So we can't just, take all the data and do interesting things with it. So what data can we use? And then we create a specific outcome for the merchant. And if ML makes sense for that use case, and that's when ML is deployed.
So what's the AP? What's the UX? So who's going to use the ML platform inside Shopify?
Inside Shopify, folks will use the ML platform are data scientists and machine learning engineers for the most part, so right?
Python.
We have something. Python, correct. Python was a big deal for choosing Ray, right? Because one of the things that we loved about Ray was that you could do the entire journey of your ML journey in Python, and that was important to us, particularly on the serving side, right? Pre-processing and online inference. We wanted that to be as simple as just writing another Python tidbit and deploying it into production. So I think product classification is a great example of how we embedded machine learning into our workflows for merchants. They upload an image for a product, they write some text, and we can surface some suggestions in terms of what classification, what category that product should belong to, right? And that helps everybody, because if the category is correct, then we can do a lot more for our merchants in terms of how we surface certain things to the buyers that are buying the products. So yeah, that was a big part of moving towards Ray as our, I would say, the compute engine for entire ML workflow.
And Azeem, for your end users, the data scientists, how do you onboard them to Ray? I mean, so do they have to? So I know the answer to this, but maybe you can explain to listeners. So can a data scientist just use Ray off the shelf? How much training?
Yeah, so it's a good question, and we're early in our experiment with Ray, right? Like we started using Ray, I think we're about 6 months into it now. So we have got a system now where they can come in, and we have a command line that they can run, and then they get a Jupyter notebook, and we've got our library that they can use to spin up a workspace, and the workspace gives them a Ray cluster. And after that, they can write Python. They do have to know a little bit about Ray today, because they have to think about how they're distributing their code and whatnot.
But not much, right?
Not much. Yeah, we don't want them to be worrying about the infra, right? Like infra is what we want to provide and what we want to manage for them.
Which is the good thing about Ray. It's almost like you can take what's on your laptop with very, very minor modifications that someone can point out to you, and then after that you'll probably know how to do it, right?
Yep, absolutely. So that is the part that I was talking about, is the minor modifications that you have to do, so you know how your code gets distributed. And in our case, we also let our users tell us a little bit about the GPUs they will use and things like that, so we can spin up the right cluster for them. And we have limits around quotas around that, so we can manage somebody coming in and wanting to take up the entire GPU cluster. So yeah, we have a few things we've built on top, but the users generally can just come in and code in Python, and yeah.
With Usually with the libraries they already love and use.
Yeah, so that's another thing. We let them pick the libraries that they want, the versions that they want, and we will build a Docker image for them that they can deploy. It's been wonderful from that perspective. Like there's a lot of flexibility, and I think that's actually one of the things, if anything, I've learned about ML platforms is you cannot be too opinionated when you're building an ML platform, particularly because of how fast the industry is moving, right? So if you restrict the type of libraries people can use, then it becomes stale very fast, the platform you have built. So giving them the ability to pick the right libraries that they want for the ML piece of it, not the infra, but the ML, gives us a huge boost.
So what are the core components of an ML platform in your mind?
I'm pausing because I think this is a moving target.
Yeah.
Right? I like to think of it as when you're going through any kind of workflow and ML workflows, there are certain complexities that you have to deal with as an ML engineer, right? Some complexities are not the complexities you want to deal with, but you have to deal with them because of where you're working. Infrastructure, how am I going to do the build? How am I going to deploy these? How am I going to run it? When is it going to run? All these other things. How am I going to integrate with other systems? How is the service going to come up? Who's going to monitor the service? All these other things. These are, I would say, accidental or incidental complexities, right? That the users have to worry about. And then there is the core machine learning work that people have to do. So one thing the first thing we look at is, hey, what are those accidental complexities that we should hide from the user so they shouldn't have to think about them? Now, I think this is a moving target in terms of how much we hide, right? Because we could go all in and try to hide everything and give them a single UI where they write some one little thing and it just works. But most people don't want them. They want a bit more control over their environment and whatnot, right? So figuring that out is one aspect of it. The other aspect is the different things that you will need in your life cycle, in your workflow itself, right? So you need to be able to train your model. You need feature store. So feature store is a key component, right? So you need a feature store where you're maintaining your features, you're monitoring them for drift, you're able to use the same feature store, consistency of feature store between offline inference and online inference. All of that, hopefully, your feature store can give to you. Then, of course, the training component, the tuning component, and the online inference. Those are kind of what we consider today are our primary components in this platform.
And
right? We are keeping it very simple.
You built your own feature store?
We're actually using Feast. Okay. So we took Feast and then we built around it.
What about experiment management and tracking? Do you consider that part of?
Yeah, so model lifecycle and versioning, absolutely, right? So when you come to inference and deploying these models into production, we absolutely consider that part of it. Today, we are not there yet because we haven't added that component yet. But we are planning on using MLflow to start tracking all the models, and then we have an experimentation engine that we will tie it with, so people can run A/B tests and things like that.
And what about
the observability? Observability is other part of it that we still don't have, and we're looking at some potential vendors to fill the observability gap right now, because I don't. So, and labeling, those two are the other ones.
Do you consider kind of a model catalog of some kind?
Yeah, so I mean, MLflow is what we're hoping will give us the model catalog. Yeah.
Right. By the way, you mentioned A/B tests.
Mm-hmm.
I think this is one area where, because we're so enamored with ML, we talk a lot about ML, but a lot of data teams actually struggle with experimentation, right? So an experiment platform, not experiment in the sense of ML, but experiment on a site, on a product feature, and so on and so forth.
Yeah.
And it's usually the companies that have this tend to be tech companies.
Yeah.
I guess Booking.com is an exception. You folks probably are an exception as well. Well, you're a tech company, but it's not there. It's kind of, in my mind, it's kind of an underinvested area. You can imagine the number, Azeem, of MLOps startups out there, right?
Yeah, they're actually coming up quite a bit, right?
But imagine if you make experimentation easy, so that's a product manager, can do it, and then there's like a company-wide dashboard where you can track. Oh, Azeem is running this experiment, so you know, and then
how
you
the
suddenly
experiments are
build this.
interacting with each other.
Yeah, you build this experimentation culture. So then your company actually goes from, or even your data team goes from just having that reporting mindset to much more of a proactive mindset. But like I said,
but I think
there's a dearth of tools and investment in this area, I think, right?
Yeah, I agree. I think there are two challenges here, though, Ben. One, I think, is the availability of the technology and tools, right? Not readily available. I don't know of any great open source like or vendors even for experimentation.
There's a wave coming, and they assume you already have a modern data platform.
Yeah. Oh, around Snowflake and all these other things, right?
Yeah. Because basically, it
makes sense.
You target your metrics are in the warehouse already or something.
Correct. Exactly. Right. So that makes sense. So I think there is one aspect. That's one aspect. The other aspect, actually, I think, is the culture within the company itself, and how much. And that's the harder part, to be honest.
But
right?
Azeem, isn't that because they don't have access to they never were exposed to it, right?
Yeah, well, so it certainly is that they never had access to it, and perhaps I think you can make an argument that if it was really easy to do, then everybody would do it, right? But I think there is something to be said about how fast we want to release certain things, right? Not within Shopify, but in general, like when you're building a product, how fast you want to release things, and experimentation can sometimes slow you down a bit, even though it might actually be a better result at the end. But in the short term, it might be a slowdown. So I think there is a cultural kind of shift that needs to occur as well, particularly in how we pursue product features.
But my thesis is correct, though. We as industry and community don't pay attention to this. We're just all focused on ML.
Yeah. No, I agree with you. I definitely agree with you. I think it is a under talked about and under invested area at this point.
Yeah, because if you think about experimentation platforms, who talks about it, right? So you folks, Booking, Netflix,
LinkedIn,
Airbnb, right? So
but the really big tech companies that are actually optimizing the specific user experience for and maximizing certain metrics around it.
Well,
right?
Why shouldn't a mid-sized company have access?
Absolutely, 100% agree with you on that. Right?
Yeah.
I think I would love to see like what's out there actually on experimentation. I haven't seen any like mature ones out there yet. But
sure by the time this episode airs, I would have had an episode with Jay Sharma of Eppo. So it's geteppo.com.
Nice. I'll check it out.
Yeah. So let's talk about actual ML use cases at Shopify today and aspirationally what you folks are wanting to do with ML.
Yeah. So today I can definitely talk about. Aspirationally, I'm not sure how much I can talk on it, but I'll in general talk about it. So today we have ML use cases around fraud detection, as you can imagine. Capital, like we give out loans to merchants, so some of that is driven through ML use cases.
So product classification. So that's forecasting, kind of.
Yeah, so that's kind of forecast. We kind of actually predict whether whether we should give a loan to a merchant or not, and what kind of loan should be
like a credit score kind of thing.
Yeah. Well, I don't know if it's a credit score, but nonetheless, we have a way to kind of say these merchants should qualify for this type of loan.
Yeah.
Then we've got product classification, which is probably one of the biggest models we have, right? That's using deep learning. It uses pre-trained models, and if we have our own bunch of work that the team has done on it. I'm not an ML practitioner, so I probably will screw it up if I talk about it a lot. But nonetheless, it's an excellent piece of work that was done recently. Going through all of our product text, as well as images to categorize our products.
So NLP and computer vision.
Computer vision for sure, right? For images and NLP, yeah. I mean, text embedding and that type of thing. But,
Yeah. That
class of
counts.
NLP products.
That
Yeah,
counts.
it counts. Yeah, yeah, it counts. We also have something that that another team did around inbox, where they were working. That's an NLP model where the text messages that are coming in can be responded to in a certain way and whatnot. Some of the we recently had an acquisition. This is public knowledge. Donde. They have a bunch of deep learning models that can do deep tagging on a given picture. So it can look at your picture and say you're wearing a jacket with a zip, with this type of collar, this type of sleeves, and that type of thing.
Yeah,
Yeah,
wow.
it's pretty neat, actually. Yeah. So that's another one. That's not. I mean, it's a company that we acquired recently, so we're figuring out how it gets used. Then we've got. I think some things that might be coming up are along the lines of recommender systems and whatnot.
And
will come up in the future.
and the goal is that the ML platform you describe will power all of these.
Correct, absolutely. So some of it today is on the legacy or the older systems, but it's all going to move to the ML platform, the new ML platform.
So the other thing that I've really been paying attention to closely, mostly because I've noticed such a big interest in the academic research community, are graphs. So
graph databases, you say?
Graphs.
Or graphs in general? Okay.
Yeah. So with a friend of mine, actually, I think by the time this airs, our post will be out. So we have this term called graph intelligence, which has two parts: graph BI, and then graph AI, which includes graph neural networks. But both of them, I think so. A couple of things that we try to dispel in the post is one, people think I don't have a graph. Well, it turns out actually your relational data can be turned into a graph, right? So, and there are tools.
Absolutely.
There are
Almost always the
tools
case.
that are free that will do that for you. And then secondly, they'll say, well, I don't have a graph database. Well, it also turns out that these modern data platforms, because they separate storage and compute, you might be able to get by without a graph database for your graph BI. And by the way, the graph databases don't actually help you for graph neural networks anyway.
Yeah.
So you don't need them for that anyway. So we're trying to get people excited about the notion that you already have graphs, and there's all sorts of research that shows that graphs might give value, and and there's now several use cases from big companies like Pinterest, Google, and Facebook that show that they're deriving value. So the question is, when do you start? Maybe you can start slow now, because we anticipate the tools will get better and easier to use, given that there's so much academic research being because I track the number of papers, Azeem, it just
skyrocketing, right? Yeah. I'm fascinated by that space, but I'll be honest, like, we are not leveraging any type of graph
yet.
Not yet. That's what I would say. Yeah, like, we don't necessarily have even knowledge systems around graph builds, right? Like, around a graph database or structured as a graph. The one thing where we're just starting is how we model our metadata in the data platform, and we're doing that as a graph.
Well, yeah, you came from LinkedIn.
So,
Data Hub.
Yeah, exactly. Yeah, the Data Hub actually doesn't store it in a graph database, but of course, conceptually, it is that way.
So
and I think Data Hub allows you to push it to Neo4j.
I should disclose I'm an advisor to Metaphor Data.
Oh, really? Are you? So
yeah,
I know Pardew and Mars fairly well.
Yeah, I mean, I think
I work with them.
They've built something very interesting. So to our listeners, I'll put a link to it in the episode notes. But they have this notion of a modern metadata platform where they combine different types of metadata. And then what they find is, if you do that, behavioral, technical, business metadata, then all these systems that you want to build on top of just get better. So their first system that they built is a data discovery, data catalog kind of system.
Yeah. I've actually, so I haven't talked to Pardew more recently, but brilliant folks, Pardew and Mars. I know both of them very well. So yeah, I'm excited to see what they come up with. I haven't seen the product yet, but
Yeah. So this is another area where I think that a lot of this kind of data ops tools
yeah,
will be better served if they have this substrate.
if they have this centralized
Yeah.
metadata catalog, yeah, absolutely. So I think we're early on our journey in terms of how far we have gotten with that. We have something of a metadata catalog today, but it's not as useful as we would like for it to be.
So did you, is that metadata platform based on one of these open source projects, of which there are several?
Today it's not. But we are looking at various open source projects to actually build a new one.
So going back to Ray, so do you folks use, I assume you use obviously Ray Core, probably Tune. So
yeah.
I don't know if you're starting to use, I've been playing around and actually I kind of like it, this Ray dataset thing.
Yeah. So I know the team has talked about it. I have not looked at it personally, so I don't know. I don't know how it differentiates from some of the other things. But we already have Spark and Flink, so we actually want to be very.
I think the way to think of it is it's more like a way to exchange data between Ray operators, so it's more efficient. So basically, and it has a few basic, these functional operators like map, flat map. It's not a full-fledged data processing system, but as you know, I mean, you can get a lot of shit done with just map.
Yeah, you can, exactly. But so this is my worry though, Ben, that what I don't want happening is confusion for our users in terms of what they use for what, right? Like, so we have transformation engines like Spark and Flink. That's what should be used for all feature engineering and transformation work, right? So the part that concerns me, like I talked about, we picked Ray because for the CPU, CPU specific, distribution of compute. So I worry about workloads, like people starting to build like heavy data set transformations on Ray, right? So we're gonna be pretty careful about that in terms of how we message it to our data scientists, because we don't want that confusion.
But I assume Tune is something you use probably, right?
So yeah, Tune is certainly something that I know our data scientists are trying.
What about do you think there's you have potential use cases for reinforcement learning, or is that?
Yeah, so it's actually a good question. I do think we have use cases for reinforcement learning, and there has been discussions around it. But I don't believe there is one that anybody is trying just yet. I think some of our principal engineers and our senior staff engineers have discussed like how we can deploy reinforcement learning in specific use cases. But it hasn't.
The only ones that I've seen in your domain are personalization and recommendation. But
around those two systems. Yeah.
But those are really kind of handful. Google and the big Chinese tech companies. So I think until the tools get a little simpler, where you have a log file, you can get started, right? So and good documentation and tutorials, I think it'll still be kind of limited to a few outfits that really want to devote resources to get it going.
Yeah. So we haven't started any work, as far as I know. We haven't. Maybe some team somewhere is playing with it.
And I know that because you have a bunch of merchants and merchant data, you probably have played around with technologies around this umbrella, confidential computing, right? So differential privacy, enclaves, maybe, I don't know. So
no, so I don't think we have we've gotten to a point where we have had to use something like differential privacy yet, although at least I'm not aware of it. So it's possible that, I joined Shopify about 1.5 years ago, so it's possible I don't know a bunch of things. So I'm not aware of it. But I do know that given kind of what I described as our model and how we think about data, I do think it will be something useful in the long run, right? As we evaluate more and more use cases that we can use.
So if you look ahead, Azeem, 12 months from now, what do you see in your machine learning platform?
In the platform itself, I see that we have our model lifecycle management figured out, the ML flow integration. I see that we have integration with a good observability layer. So we have model drift and feature drift and all of that available to our users. And I see us making a lot of progress on the incidental complexity, identifying them and squashing those bugs. So those are kind of, I would say, the three main priorities that I want to pursue over the next 12 months.
And then what about the broader Lakehouse? Where do you see yourself in 12 months?
Yeah, so in Lakehouse in particular, we want the entire Lakehouse to be Iceberg, data sets. Today, that's not the case. I want to make, I want to start paving that path for unstructured data because we don't have that yet. And we have hit our P95 5-second latency on our Trino queries. So that's kind of where
these are all basically foundational, right?
Yeah, and if you consider it, our centralized metadata layer is working and useful.
And then for me, I hope Shopify open sources its experimentation platform.
Yeah. I think we're a bit further away from that, but I'm a big proponent of open source.
The problem with experimentation platforms that companies build for themselves, it's too tied to their infra, right? So
yeah, it's purpose built. Yeah, exactly. Exactly. Yeah. So that's why I said I think we're far away from that, but I'm a big believer in open source. I think you might see other things come out that we share as we improve certain things that we're working with.
And then in 12 months from now, probably a lot of people in Shopify are using Ray without even knowing it, right?
That's what we hope. I think when we say without knowing it, I want to be careful. I think people will know that there is Ray as the infrastructure that's supporting it. But I would say it would be very seamless to do so, just in Python. Yeah, that's what I would say. Like, I think it would be hard for me to say without knowing it, because then we're kind of going into the serverless model where you don't even know the compute behind.
No, but by that I mean they don't have to worry about installing anything, and they just
absolutely. They don't have to worry about installing anything. Like, this is the incidental complexity that we want to solve for, right? They shouldn't have to worry about the specific version they're using. They should be able to bring the libraries that they want. Minimal modifications to their Python code. So it works, or they just write the Python code the right way the first time.
And with that, thank you, Azeem.
Thank you, Ben, for having me. I appreciate it.